Alright, welcome back again to our video lecture in ABE161. So we'll continue our topic on the discussion of the details of the construction. So in the previous video, we discussed already the details of the roofing systems. We say that the roofing systems basically comprises of the roofing sheets, the purlins, the trusses or rafters. Then importantly also is the roofing accessories, which comprises of the flashings, the gutters, and still many other accessories. Okay, so the flashings, they're there to protect the building enclosure from the water intrusions. Okay, so now we'll move on to the wall systems. So So the wall systems is still another major component of the building, because if the roofing systems are, let's say, geometrically they are located at the top or positioned at the top of the building, and this one is positioned at the sides of the building, so they're also the ones responsible for the covering of the buildings, or let's say the boundaries of the buildings. So the wall systems can consist of, we said earlier, that can consist of CHP walls or wall claddings, or wall claddings on gear. So this is for steel frame structures. Although steel frame structures, they can also be constructed using CHP walls. Okay, another common type for agricultural buildings, the curtain-sided walls. So for low-cost construction, instead of having CHP walls all the way from the floor line to the ceiling line, um, at least you have less materials. Uh, you The use of curtain-sided walls would really reduce the cost. So another flexibility option for these curtain-sided walls is that um, the ventilation requirements for the indoor environment can be achieved like by rolling up the curtains or by rolling it down for or during colder outside temperatures. Okay, so now let's discuss the CHP walls in details. So basically, a CHP looks like this. We have three cells here. So the dimension is we have 8 inches on this side. Alright, so 8 inches, and then okay, so 8, so times 2, we have 16 inches. So this one, this is actually the thickness. So it can range from 4 inches, 5 inches, or 6 inches. Okay, common ones probably 4 and 6. So if you have seen in PAES for bag storage warehouse, so this one was specified for the walls, so 6 inches. So you have a thicker thickness. Okay, so in construction, um, it's actually positioned in a staggered configurations. Okay, and we have these columns for examples, and we have the rebars for the columns. We also have rebars for walls, for CHP walls, concrete hollow blocks. So we have horizontal rebars. Okay. Then we also have vertical rebars at some spacings. So typically, okay, so take note, I said the word typically. because it can also change depending upon the designs. Uh, this is at every 3 layers, uh, you have to put a horizontal bars. Okay, horizontal bars, and then this one is the vertical bars. So depends upon the specified spacing. It could be, let's say, 0.6 meters. Okay, so between the walls we have actually, I mean, between the hollow blocks, adjacent hollow blocks. Okay, so we have mortars here. Okay, so that's what we call the mortar. And then after that, it's actually um, finished. The sides, the rough sides of this concrete hollow blocks, it's actually finished with um, what we call the plaster. Okay, so if you try to look at in a section view, so this is our CHB, concrete hollow blocks. This is the mortar. Then let's say this is the horizontal bars. Then the vertical bars hidden. So on this side, or on this face, as well as on the inside face, they're actually plastered. Okay, so plaster material is basically a mixture of, uh, say, concrete. I mean, not concrete. I mean cement plus sand plus some plaster materials. Okay, for this, I think this is just cement plus sand. Okay, so that's the CHB wall. Okay, so for the wall claddings on girt, which is um, common in steel structure or steel frame structures. Okay, so let's say this is our columns, steel columns. So here must depending upon the design, but let's say it's like this, configured this way. So this is our gear, and then of course it has to rest on something like an angle cleat or purlin seats on the roof systems. Okay, and then we have um, the wall cladding. So basically it's the same as the roofing sheets. Okay, so it's just that the term is called roof cladding. Okay, and then this wall cladding is then fastened. Okay, so the same roofing screw is used. Okay, so what else? Curtain sided. Okay, by the way, so for example, for the cold storage buildings wherein we need to maintain the temperature, the low temperature inside the building. So it is also necessary to include um, insulation materials. So for example, this is the wall cladding, so it sandwich the insulated materials or insulated panels. Okay, so that's also possible. Insulated panels. Okay, then for the curtain sided wall, basically it's just a curtain. So for open sided walls, let's say 1 meter wall. Then okay, so the curtain is actually here, so it can be rolled up or rolled down. So this can be also be designed in an automated way, so that it can just roll up in just one click or something like that. So roll up or roll down. Okay, so now let's move on to our flooring systems. So typically, the agricultural building is just a one-story building. So meaning that um, that our slabs is designed as slabs on grades, so we don't worry about this uh, second floor slabs, or the elevated flooring using concrete. So um, this is how I classified it. So in terms of solid floors and slatted floors, okay, although elevated flooring does exist in conventional poultry housing, so it's elevated and the flooring is just bamboo, using, I mean, in traditional poultry housing buildings, they're just using bamboo materials. Okay, but still it's slatted. So the main difference, or the main goal for this slatted flooring, is that this is for the waste production control. Since, as I've said, that livestock and poultry productions produces a lot of waste, then there must be a way to manage or control this waste. So one way is through the slatted floors. Solid floors, they're designed to have a slope that would run towards the drainage. Okay, so for solid floors, the typical material would be reinforced concrete. Okay, so the reinforced concrete, let's say this is the slab on grade. So when we say slab on grade, that's actually slabs on ground. So we have bars both ways. Okay, and then these reinforcing bars is for, I think that's for temperature control, or I mean shrinkage control, gauge, or cracking control. So it's required to have these bars so that it can prevent some cracking issues. Okay, so if you try to look at the section, we have bars like this, and then another bar on this way, or in this direction. So um, sometimes in the drawings you would see that there's also gravels here, compacted gravels. Then we have this earth fill. Sometimes there's this was not specified, so that depends. So the thickness of the slab refers to this thickness. Now this is important because I'd like to emphasize this, because the thickness of the slab, like for example in a bag storage warehouse, wherein if there's a forklift um, that goes inside the building, or that moves inside the building, then it has to carry as well the loadings of that, and as well as the stack up, uh, I mean, the weight of the bags itself is heavy, so you have to have a thicker thickness here. So actually, policy specifies that we have a 150 mm thick, that's 6 inches slab thickness, and then we have base course of 100. I mean the gravel beds of base of 100 mm. Okay, so 4 inches. Okay, so for some agricultural structures that does not experience that much load as the bag storage warehouse, then you can have a um, smaller thickness, let's say 100 mm. Okay, so also um, in processing facilities, or also in bag storage warehouse, wherein the floor is raised. It's actually raised uh, because it has to accommodate the loading and unloadings of the trucks. Okay, so for example, this is the truck. Okay, so at least the loading and unloading of trucks would be convenient. Okay, so for the slatted floors, as I have said, that slatted floors are designed to have, um, I mean, the main concern is the waste management. So basically, a slatted floor is like this. Okay, so it's an elevated flooring, but this is uh, this volume right here. This is a manure pit. Okay, and then this is the slatted floors. Okay, so if we try to view it in a section view, then probably it's like this. Okay, so the swine or the livestock is here. Okay, and then the manure drops, and then there must be a way to, let's say, some drainage or something, transport of manure. So it's like that. So this one is designed to have slats. Of course, the size of the slat should be um, adequate so that the the food of the livestock or um, the poultry bird should not pass through that. Okay, so there's uh, standards provided in the Philippine agricultural standards regarding the dimensions of the slots, and in some situation it might be available to have floorings like this. It's like a panel but with slots like this, and then you just have to um, lay it down on the, let's say, the floor beams. Okay, so this can be concrete. It's also available in concrete, or in modern materials would be plastics. Okay, so now let's move on to the foundation systems. So the foundation systems basically comprises of the footings, and then the tie beams that holds the columns together. Okay, so for the foundation, we have, for example, we have this column. Then, of course, the rest of the structure, I mean, at the end of this column would be the footing. So in side side view or elevation view. Now let's say this is the natural grade line, so NGL or natural grade line. Okay, so you notice that this footing is below the grade line. Okay, so at some distance. So the role of the footing is actually to transfer the loads above, meaning transfer the loads from, let's say, from the beams, from the floors, from the columns, actually the entire weight of the buildings, so are all transferred here. So this is something like the last line. So the footings are designed to be able to carry the loads by the supported soils, because the soil actually has some strength, but probably smaller compared to the strength of steel reinforced concrete and timber. So they are designed to spread, okay, to spread the forces. So to compensate that, it has to be compensated in the area of the footing. Okay, so actually the principle is that if your footing is just like this, and then compared a footing for the same loads, okay, like this, then let's assume the same loads and the same bearing capacity of the soil, then this can induce something like, the pressure is high, so it can probably punch through the soil. So that is why it is the footing is designed to have a wider area, so that it can distribute the forces uniformly and in a less pressure manner. Okay, so typical materials for these footings, and then the columns here, it's actually a reinforced concrete. Okay, as I also mentioned, I think in the first video or second video, that for steel frame structures, some columns are short enough that they don't need reinforcements, and we call them pedestals. Okay, but for longer columns, then there's need to have steel reinforcements. Okay, so basically the reinforcements look like this. So let's say we have 4 vertical bars. If we try to look at this, there's 4. Of course, looking from this side, it's just two bars. So we have 4 here, and then those 4 vertical bars are enclosed by what we call lateral ties. Okay, so let's say vertical bars or main bars. And then it's enclosed by lateral ties. Okay, so at this end, it's actually bent in some configures, or something like this. It's bent. Then the footing has also reinforcements. So the footing has also reinforcement on both ways. So meaning, when I say both ways, along this direction, and then another along this direction. So we try to look at that in a top view configuration. Top view. So let's say these are 4 bars. Then this is our bent bars. So we have like this. We have steel reinforcement on this way, and then on that way. Now for tie beams, let's say there is another column right here. So for tie beams, it's actually a beam that connects this. Okay, it's an underground or it's an on-ground beam that connects this column and then another column. So let's call that tie beam. Okay, so uh, what else? Another one is the wall footing. So walls also has to have some footings. So recall that walls have vertical bars. So it's bent here, and then it has also horizontal bars. Then in this wall footing, there's actually typical side or typical configurations that there's three longitudinal bars or continuous bars, and then at some spacing there must be uh, some lateral bars here this direction. Okay, so this one continues, and then it's provided with this. Okay, with these lateral bars. Okay, so far so good. We'll move on to our next topic on the next video. Uh, that would be building the building plans. We'll have a um, detailed discussion about the contents of the building plans and the templates and stuff like that, and then other documents required for the building permit applications. All right, so see you in the next video.